it would damage the entire planet, not just a house, you know.
The entire planet.
In the vast expanse of space, among the countless stars twinkling in the night sky, celestial events of unimaginable scale and power take place. Events that eclipse entire galaxies and reverberate throughout the universe. Today, we will delve into one such event, the stellar cataclysm known as a supernova. From ancient civilizations that saw these events as omens to modern astronomers studying them to understand the universe, supernovae have always fascinated us. Recently, the star Betelgeuse has dimmed dramatically, leading some scientists to speculate that it may soon turn into a supernova. If it does, it would be the brightest supernova observed from Earth in more than 400 years. Today, we're going on a journey to understand these stellar cataclysms and their impact on our planet and their story of our place in the cosmos. We dive into the fascinating world of supernovae. In the great theater of the cosmos, the stars are the protagonists. They are born, they live, and they die. But some stars give such a spectacular performance in their final act that it outshines entire galaxies. They are supernovae, the catastrophic death of stars. But what is a supernova? Simply put, a supernova is a powerful and bright stellar explosion. It occurs during the last stages of a star's life when the nuclear fusion in its core can no longer support the outer layers of the star. This causes the nucleus to collapse under its own gravity, leading to a violent explosion that can briefly obscure the entire galaxy. The energy released by a supernova is so enormous it's equivalent to the energy that our sun would radiate over its entire 10 billion year lifetime. Supernovae are not just fascinating cosmic phenomena. They play a crucial role in shaping the universe. They are responsible for the distribution of elements throughout space, elements necessary for the formation of planets and life as we know it. In fact, it's believed that most elements heavier than iron, including gold and platinum, were formed by supernova explosions. So, the gold in your jewelry, the iron in your blood, the calcium in your bones, all of these were once part of a star that was cut short by a spectacular explosion. Long before telescopes, space probes, and modern astronomy, ancient civilizations were already observing the stars. They noticed patterns, mapped constellations, and recorded celestial events. Among these events were the sudden appearances of new stars, which we now know as supernovae. One of the earliest recorded observations of a supernova was made by Chinese astronomers in 185 AD. They described a guest star that appeared in the sky, was visible in daylight for several weeks, and disappeared after about 8 months. The historical supernova RCW 86, which disappeared after about 8 months, has been identified as one we now know as a supernova. Its remnants, known as RCW 86, have been observed using modern telescopes. Another notable historical event is the SN 1054 Crab Nebula, discovered by Chinese and Arab astronomers in 1054. This guest star was about 4 times brighter than Venus and remained visible during the day for 23 days. The remnants of this supernova are what we now call the Crab Nebula. These ancient observations profoundly influenced how civilizations understood the cosmos. These historical observations challenged the prevailing notion of an unchanging universe, often associated with astrological predictions and omens. Today, we study supernovae not as omens, but as opportunities to delve into the life cycle of stars, the creation of elements, and the history of our universe. While our understanding of the cosmos has expanded, these stellar explosions continue to captivate us with their power and mystery. Recently, Betelgeuse, a red supergiant in the constellation Orion, attracted attention as it dimmed dramatically at the end of 2019. Betelgeuse's dimming led to speculation about its possible supernova eruption. However, it later returned to its normal brightness. The widely accepted explanation is that the star emitted a large dust cloud, temporarily obscuring its light and causing it to appear dimmer from Earth's perspective. When the dust dispersed, Betelgeuse's brightness returned to normal. This event serves as a reminder of the dynamic nature of the universe. The universe is not static. It's a dynamic stage where stars are born, live, and die in spectacular ways. Each star in the night sky has a story that begins long before its light reaches us. The life cycle of a star is a journey from a cloud of gas and dust to a radiant beacon. It begins in nebulae, vast clouds where gas and dust collapse under gravity, forming protostars. Over millions of years, these protostars accumulate mass and become main sequence stars, like our Sun. Main sequence stars, like our Sun, burn hydrogen in their cores for billions of years. Eventually, their hydrogen fuel depletes, leading to changes based on the star's mass. Stars like our Sun become red giants as their cores shrink and heat up, causing the outer layers to expand. Eventually, the core collapses, ejecting outer layers to form planetary nebulae and leaving behind white dwarfs. However, not all stars end this way. Some go supernova, determined by their mass composition. Supernovae vary based on the original star's mass composition, each with unique characteristics. For example, Type I supernovae, like Type Ia, lack hydrogen lines in spectral analysis. These explosions are significant events in the cosmos, shaping the universe and distributing elements crucial for planetary formation and life as we know it. From historical observations to modern study, supernovae continue to reveal the dynamic nature and profound mysteries of the universe. In a binary stellar system, a white dwarf, the dense remnant of a star similar to our Sun, sucks matter from its companion star. Once the white dwarf reaches a critical mass, it undergoes a thermonuclear explosion resulting in a supernova. On the other hand, Type IB and IC supernova are thought to result from the collapse of the cores of massive stars that have lost their outer layers of hydrogen and, for Type I, helium. Now let's focus on one of the most common types of supernovae we observe, Type II. These supernovae originate from massive stars much larger than our own Sun. Stars with at least 8 times the mass of the Sun can undergo this dramatic transformation throughout their lives. These massive stars are in a constant battle between gravity pulling inward and the force of fusion pushing outward. When a star exhausts its nuclear fuel, gravity wins the battle. The core of the star collapses under its enormous gravity. This collapse of the nucleus occurs incredibly quickly in just a fraction of a second and leads to a powerful explosion, a supernova. The outer layers of the star explode in a spectacular spectacle, outshining the entire galaxy for a short time. What's left of the star may form a dense neutron star or, if it was massive enough, a black hole. But the legacy of the star lives on. The explosion disperses the elements formed during the life of the star into space, seeding the cosmos with building blocks for new stars, planets, and even life. When a star goes supernova, it's not just a spectacle of light. It's one of the most energetic events in the universe. The amount of energy released in a supernova explosion is so enormous, it's equivalent to the energy the sun would radiate over its entire 10 billion year lifetime. But where does all this energy go? Most of it is carried away by neutrinos. These tiny, nearly massless particles are produced in huge quantity during a supernova. They travel at nearly the speed of light, taking about 99% of the explosion's energy with them. The rest of the energy is released as light and other forms of electromagnetic radiation. This includes gamma rays, the most energetic form of light, and X-rays, which are less energetic, but still much more powerful than the light we see. The visible light from a supernova is so bright that it can briefly obscure the entire galaxy. This light can be seen at great distances, making supernovae important cosmic beacons for astronomers. Although supernovae are interesting to observe, they can also pose a potential danger. The enormous energy and radiation released in a supernova explosion can have significant consequences, especially if the supernova is close enough to Earth. One of the main causes of concern is the impact on our planet's ozone layer. The ozone layer acts like the Earth's sunscreen, protecting life from the sun's harmful ultraviolet radiation. But an intense gamma ray burst from a nearby supernova could destroy the ozone layer, increasing the amount of UV radiation that reaches the Earth's surface. This increased UV radiation can have harmful effects on the Earth's biosphere. It can lead to higher rates of skin cancer in humans and other animals and disrupt photosynthesis in plants, potentially affecting the entire ecosystem. In addition to gamma rays, the supernova also emits a stream of high-energy cosmic rays. These particles can further damage the ozone layer as well as create streams of secondary particles in the Earth's atmosphere that would increase the radiation dose. In our study of the dangers posed by supernovae, there's another interesting aspect to consider: gravitational waves. These are ripples in the fabric of space-time caused by some of the most violent and energetic processes in the universe. Albert Einstein predicted the existence of gravitational waves in 1916 in his general theory of relativity. Einstein's mathematics showed that massive accelerating objects like a neutron star or a black hole orbiting each other would collapse space-time in such a way that distorted space waves would emanate from the source. And supernovae, with their incredible mass and explosive energy, are the first candidates to create such waves. When a massive star collapses and when a supernova explodes, the asymmetry of the explosion can potentially create gravitational waves rippling through space. These waves will be incredibly weak by the time they reach us and will pose no danger to Earth, but they give us a new way to study the universe. Scientists have already begun to detect these waves with incredibly sensitive instruments, ushering in a new era of gravitational wave astronomy. Fortunately, the probability of a supernova exploding close enough to affect Earth is quite small, but understanding these potential dangers is crucial. It's a reminder of our connection to the cosmos and how events occurring light years away can have consequences right here on our home planet. As we've seen, supernova explosions are powerful events that can have far-reaching consequences. But did you ever guess that supernova may have played a role in shaping Earth's history? Scientists have found evidence of past supernovae, in the form of iron-60, a radioactive isotope in ancient geological layers and cores of Antarctic ice. Iron-60 is not naturally produced on Earth but created by supernovae, suggesting that our planet was dotted with the remnants of these stellar explosions. One notable event is the Pline supernova, which erupted about 2.7 million years ago. Some scientists speculate that this supernova may have affected Earth's climate during the Ice Age, perhaps even contributing to a period of cooling. There's also a theory that supernovae may be associated with mass extinctions. The idea is that cosmic rays from the nearest supernova could damage the ozone layer, resulting in increased ultraviolet radiation on the Earth's surface and harming life, especially shallow oceanic organisms. Although these theories are still being studied and debated, they highlight the potential impact of distant cosmic events on our home planet. It's a reminder that we're part of a dynamic and interconnected universe. As we look out into space, we're looking not only to the past, but also the future. Stars will continue to be born, live, and die, and some of them will end their lives as supernovae. But what does the future hold? For supernova in our Milky Way galaxy, astronomers estimate that a supernova explosion in the Milky Way occurs on average about once every 50 years. However, most of these supernovae are not visible from Earth because dust and gas block the direct view. The last supernova visible to the naked eye in our galaxy was over 400 years ago, observed by the famous astronomer Johannes Kepler. But rest assured, astronomers are keeping a close eye on potential supernova candidates. These include such stars as Betelgeuse and the constellation Orion and Eta Carinae in the constellation Carina. Both massive stars have unusual behavior, leading astronomers to speculate that they could become supernovae in the relatively near future. On an astronomical timescale, a recent study has shed new light on the mysterious behavior of that celestial giant, Betelgeuse. This star, known for its semi-regular variations, has been the subject of intense scientific scrutiny. In the context of a star such as Betelgeuse, these changes are visible in brightness or intensity. Of light, the star does not follow a strict cycle of increasing and decreasing brightness, but rather oscillates in a predictable but not entirely regular manner. Researchers have identified 4 different periods in the variations of Betelgeuse: 200, 420, 230, and 185 days. They suggest these periods correspond to the pulsation patterns of the star, in particular the radial principal mode and the first, second, and third overtones. This pulsation analysis, which takes into account the complex interaction between pulsation and convection, suggests that Betelgeuse is in the late stage of core carbon combustion. The study also looks at the previously mentioned event known as the Great Dimming, which caused Betelgeuse's brightness to decrease significantly from December 2019 to February 2020. Researchers speculate that during this period, the effective temperature of Betelgeuse dropped by about 100 K, which may have resulted in significant mass ejection of the star. This event triggered a flurry of observations and analysis aimed at deciphering the secrets of this distant star. The researchers' findings lead to an exciting conclusion. Betelgeuse could be the next star in the galaxy to go supernova. Given the current stage of late-burning carbon in the core, its high luminosity and complex variations, Betelgeuse is a prime candidate for participation in this exciting cosmic event. The study also notes that the star's high rotation rate as a red supergiant has sparked discussions about its evolution, including the possibility of past mergers with another star as a source of angular momentum. However, it is important to note that predicting exactly when a star will go supernova is extremely difficult, because it depends on many factors that are not fully understood. Even if a star has indications that it might go supernova, it could be thousands or even millions of years before it actually goes supernova. But rest assured, when it does, it will be a grand spectacle. The study of supernova is crucial to our understanding of the universe. These stellar cataclysms are not only endpoints, but also beginnings, saturating the cosmos with the elements necessary for new stars, planets, and possibly life. As we travel through the cosmos, we're constantly reminded of the grandeur and mystery of the universe. Supernovae are a testament to the life cycle of stars, the creation of elements, and the interconnectedness of the cosmos. We have studied their types, the dangers they pose, their impact on our history, and what the future may hold. These celestial events, as destructive as they are also creators. They seed the universe with the elements necessary for new stars, planets, and possibly life. Studying supernovae is not only about understanding the spectacular events, but also about understanding our place in the universe. They remind us we are made of star stuff, that we are part of this vast, dynamic, and constantly evolving cosmos. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.